Matthias is here, your trusted advisor. Let's talk about Microsoft Data Warehouse in Microsoft Fabric. Data Warehouse is a very central component because you need it when all your data is ready and you want to warehouse it, to serve it for reports, for anything enterprise data processing. So this is often the area where the input data becomes a star schema. So this is like the central point in a data ingestion flow, or it's like the endpoint, the goal in a data ingestion flow. Let's go a little bit into the details. As always, I have my iPad with me and I will draw the conceptual things. Let's start with the Microsoft Fabric periodic table, because there we have the SQL warehouse in there with all the details. So you see it's like enterprise grade, of course, it's T-SQL first experience, and you have all the key features listed. You have a variety of different basic scenarios. We will go a little bit deeper today. All the technical stuff with the naming conventions and the licensing information right here. So I think that's a great reference. It's always a great start point. And so let's go. Usually you have a medallion structure. We will go a little bit into that later. But you start often with some Lakehouse. In Fabric, you have Lakehouses and warehouses. Lakehouses are the more lightweight approach. We will go a little bit more into detail for that later. But general, when you build a medallion structure, which means bronze, silver, gold, you have Lakehouse, warehouse. So that's why we have a Lakehouse here. In the Lakehouse, you have the Spark engine for data processing, and you have a SQL analytics endpoint. But this endpoint, and this is the main differentiator against warehouse, is read only. So this is like one input area for your data for the data warehouse. You have then beside that the Fabric data warehouse. Let's make it blue today. Fabric data warehouse. And you will see that we have a much richer feature set in there, because we can read and write data through the SQL endpoint. So this is like for the T-SQL first experience. First, you have, of course, tables and views in this Fabric warehouse. You have the T-SQL engine with read-write capabilities. And you have all the security layer, right? With row level security and column level security, and all the data masking. So this is like our warehouse experience. Go to that. And all this, both, and this is one of the great stuff in Microsoft Fabric. All this is combined in your OneLake. OneLake is your storage layer. OneLake works with Delta tables and Parquet format. Delta, Parquet, and V-order. V-order is very important for the performance. So this is the OneLake, and both work with that OneLake. So the Spark engine is accessing OneLake and also reading data from OneLake. The SQL analytics endpoint from the Lakehouse is reading from OneLake. So basically we should make it just the other way around, reading from OneLake. The Fabric data warehouse is reading and writing from OneLake. like that. So everything comes together in one lake, which I think is really nice and quite important. And of course, as always, you have the data consumers. And you have all the great consumers as you have in Fabric. Always is like Power BI. You have the SQL Server Management Studio or the Azure Data Studio. You have notebooks, which is Python code basically, and you have all the third-party apps that can access your data. So this is the rich set of potential consumers, not to mention things like the GraphQL, REST API, and so on. So they can all, and more, right? Think about data agents, but well, all this is served by the T-SQL engine. So I will just draw one line from the consumers to the T-SQL engine, and all this respects the security. It's quite important. So this is like the big picture, the Fabric architecture warehouse overview. So I already mentioned that one main differentiator is the read-only capability of the Lakehouse and the read-write capability of your warehouse. So let's go a little bit more into detail for that point. So basically you have always a lot of different data sources. So for example, you have databases that you want to import or that you want to get into OneLake, into Microsoft Fabric. You have REST APIs that emit data, and you have usually also files, which can be CSV or Parquet format. So these are all our different data sources that typically go into Microsoft Fabric. Now you have your lakehouses and you have your warehouses, and both data can go into both areas. Let's start with our warehouse. So this is our Fabric SQL warehouse. In the warehouse, we have as a main engine the full T-SQL engine with the data definition language, data manipulation language, and the data query language. So this is the meaning of full. You have the full capabilities there, and you can access all your data from databases, from the REST APIs, and even from files, all with that engine. Next, beside that, we have tables that you can query, you can manipulate, you can create. You have views. You have even materialized views now. You have stored procedures for programming. Procedures. And you have the security part with row level security and column level security. And the SQL permissions. So this all forms your warehouse experience, which is very, very rich. In opposite of that, you have the Lakehouse experience. The Lakehouse experience is much more lightweight because Lakehouse has like a different purpose. In Lakehouse, you have the Spark engine. In opposite to the full T-SQL engine, with the Spark engine, you have read-write capabilities. The Lakehouse sits directly on Delta tables. which means that every table is represented by a file in OneLake. Yes, you have, let's draw it like that, and this is our Lakehouse. Yes, you have a SQL endpoint. But the SQL endpoint is read-only. So it's not so universal like in the warehouse experience. And you have only views. You have only views that you can create. So let's draw a nice box around that, like for the warehouse. So what's the main difference? What's the idea? So for warehouse is built for SQL first teams. If you love SQL, you should go with warehouse. So this is like a SQL first experience. It's for enterprise data warehouse, and it's made for transactions. And it's made for speed. It's really fast. Lakehouse is made for data engineering. It's made for machine learning pipelines. And it's made for Spark workloads. So that's the main purpose of the Lakehouse. And that's why in typical data ingestion patterns, where we should go a little bit more into detail now, data ingestion. Let's talk about data ingestion. In data ingestion patterns, we have the Lakehouse warehouse in pattern for bronze, silver, gold. It's very, very common. So you have, again, when you talk about data ingestion, like external sources. You could have different sources. At the top diagram, we were a little bit more generic, like you can have databases, you can have REST APIs or some files. Let's be a little bit more specific here. So you could get data from Azure Data Lake v2 storage accounts. You could get data from Azure Blob Storage. You have other sources like Amazon S3 buckets and so on, but I think you get the idea. So these are like storage accounts, either hierarchical storage account or flat storage accounts. You could get data from SQL Server in any way. When you want to go direct, you could, for example, use Azure SQL, and you have, of course, Microsoft Fabric SQL database, where I've made a different video. And you could have different software as a service apps like Salesforce, like SAP, and so on, just to mention the most prominent ones. For these different types of data sources, you have different ways of ingestion. For the storage accounts, you typically use copy into. Copy into has high throughput. It's very fast, and it's a very preferred way for getting data from Azure Blob Storage or any other blob storage. For SQL Server, you have different ways. You could use a data factory pipeline, which gives you a lot of flexibility because you can design every step. You could also use cross-database queries, with insert and select. different way. And for SaaS applications, you typically use data flow Gen 2, which is the former Power Query. So you have different ingestion methods. In either way, your data goes into the Fabric warehouse. That's nice. Let's change the color. Warehouse. All this data goes into the data warehouse with in some way. So let's assume you stage all your data in a warehouse. Then you have the staging schema here. With all your raw data. And everything comes in here. From each different source, the data is coming into your staging schema. And from there, you transform your data into dimension tables and into fact tables. Fact dot asterisk. So these are the main transformations. And once you have done that, you have your star schema. So that's the way how it works. Some best practices, of course, you should use parallelism wherever possible when you have a lot of data, like copy into. And you should use CTAS for transforms, which means that you have a parallel operation. CTAS is the simplest way. CTAS means creates table as select. So this is a typical way where you create a table out of a select from a different table. So this is the way how the data gets typically into the warehouse without a lakehouse. There are different scenarios where you combine lakehouse and warehouse, and this is where the medallion structure comes in. So let's enhance our schema. So it not only uses the warehouse approach, but it also uses the lakehouse approach. Again, you have a lot of data sources. As we have mentioned, you could have real-time data, like event stream. You could have SQL data, either in Azure, either on-prem, you name it. You could have data from cloud DBs. You could have data from storage accounts like Azure Data Lake v2. All that could be different data sources. This then runs into some activity. Everything goes at the end into your lakehouse. So this is lakehouse for the bronze and silver layer. The idea is bronze equals raw data, and silver is like the transformed data that you can use. So you clean up your data. So silver is basically cleaned. And all the data goes into the lakehouse, but in different ways. The real-time data, the event stream, typically goes directly into the lakehouse and the bronze layer. The on-premise or cloud SQL or cloud DB or whatever have some kind of orchestration pipeline. So they go both through orchestration pipelines, and the file data is typically copy. So that's a different activity. So all this went into your Lakehouse as bronze and silver. And from there, you want to move all that stuff finally in your enterprise warehouse. Warehouse is your gold layer. Gold means ready for reporting, ready for data products, ready for data mesh. However you name it, it's ready. It's a final data product. And you could use some processing like notebooks with complex logic, or you could simply use cross DB calls for just getting the data from silver to gold. It depends on your data quality, but finally everything ends up in your data warehouse. So this is like the processing layer. Processing. And your data warehouse then is the serving layer. So this, let's go with green. This is serving. Serving your data for the enterprise. So yes, you have your data in the warehouse, but from there you could build on top semantic models. How near or far the semantic models are on top of your warehouse depends. Depends on the quality of your star schema structure, depends on third-party tools like dbt or SQL Mesh or something like that. But anyway, in some case, you usually want to build a semantic model on top because you get additional logic inside there. But still, you have at the end, again, our consumption layer. Oh, that's not nice. Consumption. This is a consumption layer. We have all the latest and greatest tool sets here, like Power BI, like Excel, like paginated reports. And you might imagine much more. For the semantic models, you could, of course, connect directly Power BI, but also different things like Fabric IQ. Excel, you could also directly connect to your SQL warehouse, Power BI too. And paginated reports also could go directly with your warehouse or with the semantic models. So you have different ways, but in the end, you have these layers like bronze and silver, where you use data warehouses, and gold, data lakehouses, excuse me, and gold, where you use data warehouses. Typically, of course, you use two different lakehouses for bronze and silver, but you don't have to. From a technical point of view, that's flexible. So these are the different layers, and bronze, silver is lakehouse, and gold is typically warehouse. I already mentioned that you have different SQL capabilities in your lakehouse and warehouse. So let's go a little bit more into the details. What are the differences? So let's, on the left side, red, draw the lakehouse. And on the right side, warehouse. So on the left side with the lakehouse, you have for the SQL endpoint, this is about the SQL endpoint, you have just a data definition language. You have views. And you basically don't have tables because the tables are sitting in OneLake technically, right? This is read-only. When you want to modify your data, you have to use Spark. For modification, you need to use Spark. You can, of course, you have a data query language. For data query language, you have the full feature set. So let's take a green check mark there. So you can do it select and join. You have full query support, but you don't have any no transaction support. So this is red, and the modify part with Spark is also red. So this is really missing, and everything is read-only. When we compare it with the warehouse SQL endpoint, you have a full data definition language with create and alter and drop all the capabilities. You have tables, you have views, and you have stored procedures. For the data manipulation language, you have everything. You have like insert, update, delete. You have merge, you have truncate. So green check mark on data definition language, green. There we go. And green check mark on data manipulation language. Regarding data query language, you have select, join, and you have functions. So also green check mark. Regarding transactions are in. So when you compare that, data definition language on the left side, you have only views, everything is read-only, and no tables, right? Because everything is sitting in OneLake. For the DML, you have only read-only, right? So no insert, update, and so on. The data query language is almost comparable, and the transactions are not comparable. So this is red, this is red, and this is red, and only this one is green. So well, that's it. So when you want a full-fledged SQL endpoint, you should go with warehouse, obviously. Last but not least, let's talk a little bit about security, because security is also different. I need some free space. There we go. So let's go into security. We have some free space. You have different security layers. First, we have the workspace level in Fabric. In Fabric, everything is organized into workspaces. So workspace level. In workspace level, you have the admin role, which has full control. You have the member role, which can create, edit, and share. And you have the contributor role, which can create it and edit, but not share. That's the main difference between member and contributor. And you have the viewer role, which is obviously read-only. So this is the workspace level permission set that you have. And beside that, you have item permissions. For the item permissions, you have read and query data, You have read all for the underlying files. You have write and modify schema. And you have the capability of build and create reports. So for different items, you can have different layers of permissions. And beside that, you have the SQL security, which is a different thing. SQL security means you have row level security, so you can filter rows depending on the security membership or different criteria for a user. You have column level security. So this is like filter rows by user. This means hide columns. And you have dynamic data masking, DDM. Dynamic data masking means mask sensitive data. So this is like the SQL security layer. And all these three are combined in Fabric. So all these three define our Fabric security layer. For SQL Warehouse, of course, nothing else. We're just talking about SQL Warehouse here. And you have different personas, right? When we talk about the data platform team, they typically have admin. When we talk about data engineers, they typically have the member role. When we talk about business analysts, they typically have the viewer role, and they have permissions in typically for row level security. So the data is filtered. And when we talk about external partners, well, it depends. They might have column level security applied, row level security applied, dynamic data masking applied, and they might have some permissions still in your Fabric workspace, like the viewer role, right, to get the data. So this is the basic security model. We should go a little bit more into detail in a different Fabric Friday, but I think for the very overview for data warehouse, I think that's quite helpful, I hope. So let's go a little bit into common questions from the community side. So one of the top topics, as you can think, is when should I use warehouse and when should I use Lakehouse? So a lot of users are uncertain whether they should go with Lakehouses or warehouses. So warehouse is a T-SQL first experience. When you have T-SQL or SQL devs, then warehouse is the best way when you want to get all the SQL features like write data, read data, transactions, and when performance is very important, then and performance optimization, then warehouse is your friend. Lakehouse is a Spark first experience. When your data engineers work with Python, then this is the appropriate choice. In the end, it's a better together pattern, because when you go with a medallion structure like bronze, silver, gold, then bronze, silver is Lakehouse, and gold is typically warehouse. You can do cross-database queries, as we have pointed out, which means that you have an easy way to get data from Lakehouse to warehouse. There are some performance issues with the copy into activity in the community. So for example, when you have a lot of small files, smaller 4 megabytes, then the performance can get degraded. Parquet is much faster than CSV, to point out that. You could go with parallel copy into activity. So this makes things a little bit faster. And in general, Azure Data Lake storage performs better than blob storage. When you have singleton insert into then your performance can be really, really bad. So when you build your ETL workflows with single insert statements, things are not running fast. The solution is create table as select setters, because this is a mass operation. It's much faster. You could stage tables with truncate and insert and select, and you can go with batch operations. In general, it's more about moving masses than doing single inserts. Single inserts are making performance really, really worse. Next question often is about, should I use direct lake with warehouse? Is it better than import? How is the performance comparison between direct lake and import mode? Key takeaway is direct lake works perfectly with warehouse. You don't need import. You can go directly from direct lake. You should take care about reorder optimization. We will have a Fabric Friday about performance and warehouse, so we will go a little bit more into that. When you have large data sets, then direct lake is even faster. When you have still Azure Synapse, how to migrate to Fabric Warehouse? Well, beside of moving your data, which is quite well documented, be aware that the T-SQL is very similar but not identical. So there might be issues with your T-SQL statements. You go through it, right? And you don't have distribution keys. This is managed by Fabric automatically, so there might be a good chance that you have to adjust your distribution keys when you have defined them in Synapse. So that's a little bit about all the community questions. There are some more, for example, like how do I optimize query performance in data warehouse? Think about vOrder. We will talk about that next time. The statistics are automatically built in Microsoft Fabric. You should use proper data types, not everything with varchar max. Could you use linked servers in Fabric Warehouse? No, you cannot, but you have cross-database queries that you can use. And for external data, you should use pipelines or shortcuts, depending on what's possible with your data source. So how does security work in Fabric Data Warehouse versus Azure SQL? We have the Workspace rules. We have talked about that. We have item permissions for granular control. You have SQL security with row level security, column level security, and masking that works as you know it from SQL Server. You have Entra ID authentication. You don't have SQL authentication. That's from the architecture side and from the community side. Let's have a look how the warehouse works in Fabric in the demonstration part. And we are in our Fabric workspace. We create a new item, and obviously this new item is a new warehouse for the worldwide importers. This warehouse is created in the background. I have cut everything a little bit so it's more speedy, and we want to get data in, which means that we create a pipeline. First, we want to get customer data in the warehouse. The customer data is stored on an Azure Blob storage account, which is public available. There pops a wizard up. We exit that wizard and import the data by our own. So we add a pipeline activity, and we want to copy our data from source to destination. So this is load dimension customer. And you see we have source and destination that we need to define for this copy data activity. For the source, we have different sources that I have already used in a variety of sources of demonstrations. But we go to browse all, search for Azure Blob Storage, and then enter the URL, hit connect, and basically that's it. It's very simple. There we go. And we need to define the exact file path. This is predefined, given by the container. So this is sample data, wide world importers / tables, and then the table name, and the table name is Parquet format, dimension customer.parquet. The format obviously is Parquet, so we need to adjust that. And the next thing is that we need to define the destination before we can preview our data, which is helpful because then you know that it works. So let's hit preview, and after some seconds the preview pops up, so there's obviously data loading works. Then we can go to the destination. Regarding the destination, we select browse all, go to the OneLake catalog and select our target lakehouse. Basically that's it. It's very simple. We can then save our pipeline and run it. Oh no, I forgot. We need to enter the table. So DBU dimension customer is our table. Hit auto create, save and run. And the run is pretty fast. I ran it one time and I forgot to select that the table must be created. So this produced an error, but I have cut that out for your convenience. And now the pipeline is running very fast. And after that, we will have the data in our warehouse. So run succeeded. We can jump over to our warehouse or jump back to our warehouse. Everything is great. And see whether the data is already there or not. Very, very straightforward. There you go. And you can start with querying the data and creating new data. So this is the next step. We create new tables, 2 new tables. This is standard SQL. I think you know that. So you can also create tables by SQL. Of course, you don't have to import the data. I will try to name the important queries so we can see them. And when we go to DBO and tables, you'll see we have the dimension customer that we have imported, and now we have the fact table and the dimension table that we have just fact sale table and the dimension city table that we have just created. Very, very straightforward. So next we can import data from a Parquet file. So basically it's the same blob storage. First we make a select top 10. So we have a preview. This is more or less the preview functionality that we have in the pipeline. But from SQL, this is of course great for one-time imports. So we see that the data is great, and next we can import these Parquet files from OpenRowSet into our tables. So let's replace our SQL code, and then let's run the import. There we go. Copy into, from, and that's it. So this is very, very easy. Of course, this query takes a little bit longer because we need to import all the Parquet files. But the result is the same as if we would have imported that with the pipeline. The benefit from the pipeline is that you can schedule the pipeline, run it several times, and add additional and more complex logic. So the result might be better aligned to the things that you really need in your business compared with one-time import. So data is here. We have a preview of the fact sales table. Looks great. Let's continue. So we will create more tables, and this time we will create a clone. So dimension city 1 and fact sales 1 as clone. It's very simple. We can clone tables. And after some seconds, you will see that we have a clone table now. So this is also possible. And what we also can do is we can do a time travel. So we can jump back in time. So I will show you in a second the SQL code. This is capable of doing that, and a little bit later we will jump back in time because we then change some data. You see it's add as clone add. So we can clone data back in time, which is helpful. So this is one way how we could achieve time travel when we clone the data back in time. And we have different options for time travel, which we will see in a second. So let's continue. Next, we create a new schema DB01. And then we create, or we could create a new fact sales table in the new schema. I don't think that we need to do that here, but I think you get the idea. It's very easy to create clones of tables in the data warehouse, and that's very handy for defining your dimensions and the fact tables and all the data processing. Next, we will create a start procedure. The start procedure will aggregate our cells by city, and we have the predefined SQL code here, which is kind of intuitive. So let's run this. And after the start procedure was created, I have selected text there. This is why first run failed. So this creates the start procedure, and after the start procedure is created, we can see the start procedure in our user interface. So then we can run it. Let's create a new SQL query where we then can paste our, that was a wrong clipboard content from my side. So execute the populate aggregate sales by city. Let's run it. It takes not a long time. And afterwards, we can go into the tables. We will have a new table with the aggregations directly ready for anything that we need. So it succeeded, 15 seconds. Let's refresh our tables, and we will see that there's a new aggregation table in there. There you go, it's refreshing, and there we go, it's the aggregation table right on top. And you see there's a city aggregation that we have just defined in our start procedure. Very, very straightforward. Next, we will create a top 10 customer view. This view is created for the purpose of showing you the time travel. So it's a simple view that shows you the top 10 customers. I will save the view with a name. This is a bit tricky because at the moment there's a small bug in the user interface, which means when you try to rename a view, then you need to close all things with the cursor. But I renamed it. You see it. The Moore, Tailspin Toys and Moore is the important thing. Just realize or remember yourself that it starts with a 6. It's the third line. So now we are adding some total including text on top for Tailspin Toys Moore, Michigan, with a sales key, right? So let's jump back, and you see it's row number 3. There we go. You see it with this, yeah. So when we add it, we could expect that the first number is higher. That's the point. And you see we retrieve the current timestamp. The reason is that I want to show you time travel. So this is the current timestamp. We will need it when defining our. So this is time travel. Yeah, perfect. And then we will need the timestamp when we want to do the time travel. So you see there is a placeholder your timestamp, and I copy the timestamp. There you go. Copy results. Go back, insert the timestamp, and copy it in the right position. And then we obviously can expect that we will get the latest version of the data because this is when we did the change. And you see it's now an 8 at the beginning, and it moved a little bit up. It's now number 2 of our top 10 customers. So what we can do now, beside of renaming the query to a proper name, is changing the minute, just 1 minute earlier, 31, and there we go. And you see now it's still number 360. So this is the time travel functionality that you also have in the data warehouse, which I think is very, very handy and very helpful, and very intuitive. Of course, you could integrate that with the start procedure and all that great stuff. We have also a visual query builder. So let's add the fact sales table to the visual query builder. We can reduce the rows. We can keep the top 10 or 100 or 1,000, in this case 10,000 rows. And you see there's an icon added, keep top rows. Let's throw in the dimension city table. And we can also transform the dimension city table in a variety of ways. So for example, we can combine both queries. For that, we will use the city key. So let's select the city key on both tables. First on the dimension city, second on our fact sales. So this is the city key and this is the fact sale table, and we select the city key. And then we can adjust the join mode. We have left, right, and inner join and all the good stuff for outer join. And we will select the inner join here. And after we have done that, we have joined both tables in a visual way, which I think the interface is great. So this is the merge. And we see the result straightforward in the preview. Next, we can expand tables. So we have now the fact sales table, and we can select the keys that we want. We don't want to see all the keys. So let's go to our profit and tax amount and total including tax. These are the three that we need. And after some seconds, we will see these keys here. Next, we can group and transform this. This is a great interface because we can add several aggregations on one grouping. So we need to put the group in the right way by country, state, province, and city. And then we will create the first column. This is sum of tax amount. This is sum, obviously. And when we scroll a little bit down, it's a small screen here. Yeah, this is a column, right? This is, by the way, not correct. I need to readjust that later. I realized that after I recorded the screen recording. So this is, of course, the sum of tax amount, because the next one is sum of profit. We select again sum as an aggregation method. And there we need to select tax amount, and here we need to select the profit, quite obviously. And we will need the third aggregation, which is sum of total including tax. Again, it's the sum. And there's a field total including tax, which is the right one. After that, we can hit OK. And we see that we have added groupings with aggregations in a very easy and nice way, I think. And this is the benefit of the visual query builder. So we can rename our query to sales summary. And we have done it. So yeah, we have imported the data. We have defined our queries. So that's great. What we also can do is we can work with notebooks. So let's create a Python notebook on the Spark cluster. Let's select the warehouse. It is already selected, by the way, so this is why it's grayed out. And there we have the DBO and all our tables. And it's a very, very intuitive interface, at least for a notebook, because you can simply select a table and right-click and say, okay, I want to add the rows. So for example, this is dimension city. I'm unsure here whether this is dimension city 1 or dimension city, but in the end it's not important. Select top, in this case 100, and you see I selected the wrong one. And we can run the cell. So that's our demonstration. We went all through this: data import, data aggregation, stored procedures, data querying. So, well, thanks for joining me today. If you want to be notified